Hello. Very good afternoon, participants. We are starting the next session very soon.
Good afternoon, everyone. Welcome to the keynote session, day 1. I request all the dignitaries, including our session chair, Dr. J.S. Thakur, co-chair, Dr. Agya Mishra, convener of the conference, Dr. Kamal Kushwaha sir, and our keynote speaker, Mr. Ravi Kumar Verma, to please join us on the stage. I request Dr. Shilpa Saxena ma'am to please join us on the stage. I request Dr. S.K. Mahobia, Professor, Applied Physics Department, to please welcome our session chair, Dr. J.S. Thakur. Sir, please welcome our session chair with a token of gratitude. I request Dr. Durgesh Nandani to please welcome our co-chair, Dr. Agya Mishra, with a token of gratitude. I would request our convener, Dr. Kamal Kushwaha sir, to please welcome our senior professor, Dr. Saxena. For keynote session, Mr. Ravi Kumar Verma is present with us. He is senior space scientist from ISRO Ahmedabad. Sir is active member of numerous technical committees like numerous committees of spaceborne projects at ISRO. He is also secretary member of Universal Testing Machine, Bond Pull Testing Machine, Microbalance, and Thermal Mechanical Analyzer. He has been actively involved in numerous research and development activities, space technology cell and IITP projects, with numerous papers and patents granted on his name. We welcome you, sir. I request Mr. Ravi Kumar Verma. I request Mr. Ravi Kumar Verma to please deliver his lecture.
फॉर्मेट ही बदल दो एक दूसरे ही आ रहा है ना हटा दो उसको इसको भी हटा दो ये भी हटा दो तभी तो आएगा बंद कर दो हाँ उसको पहले ऐड कर ऊपर से करो ये हटा दो पहले ना ये तो बोल रहा हूँ चलो छोड़ दो छोड़ दो छोड़ दो Thank you. So good afternoon, everyone. So I'm going to talk about on novel materials, right? The conference topic is there. So as the morning session itself, the madam has given some idea about how the new materials actually evolved for data science and other applications, right? So I will concentrate not going for each and every material, what is the definition and what kind of materials are there. I'm going to talk about why these application of these materials are there, means especially for aerospace and space applications, right? And this forum is open. You can have the question. We can have an interaction with one by one, right? So whatever your questions are coming in your mind, now that we can discuss after my presentation. And sorry for this, because my voice is not clear. Little bit congestion is there, but still I will try to communicate what actually for that I have invited for expert lecture. So what do you understand about noble materials? How it is different from conventional materials? Why such kind of materials are required for a new cutting edge technology, or for, I can say, since I belongs to space field, why we want to use such kind of material, especially for our satellite development, launch vehicle development, payload developments. Yes. जोर से बोलो ना. For efficiency purpose. Okay. So what is the drawback of conventional material? What kind of efficiency you are talking about? No, efficiency means what kind of efficiency? Strength means you are from mechanical background. Only strength point of view. Right. No, when the first lecture was there, it is given by that madam. She told us self-healing materials are there. What kind of self-healing? Now, why this kind of materials are required? The main purpose of self-healing is material basically for space and aerospace. Na, every kg or I can say every gram is important, right? In general means it is a space market. Na, that's what I'm telling. In general, 1 kg means if you are going to LEO, low Earth orbit, it costs near about $1,000. If you are going to GEO means geostation 36,000 kilometers, it costs near about 30. It costs around $10,000. Understood? For 1 kg, it means it is the penalty for us. Because when you talk about, let us suppose new category of materials, right? Same time you have to see whether this material is economical or not. Na? Because that's why all satellite and rocket cost is very high. So when you are going to use such kind of material, when we want to use that material, you can trigger on or I can say initiate their process. And once there is no requirement, automatically they will, as their situation is there, they can kept on, right? Such as a human body, right? We have the sense of self-healing, right? कुछ भी problem होती है, then definitely our body will rectify it, right? So self-healing, such kind of material, right now we are developing, especially for humanoids or new category of robots are required, especially if you are going for a plan for a Gaganyaan mission, right? Now the next question is there, before going this, why we are sending a human in a space? Robots are the good alternate, na? And sending a robot is very easy as compared to humans. It is a less cost. Can say such kind of payload we are developing, and since I belong to material field, so my responsibility to select the right material for the right purpose. In my lecture, in my morning session, I told a selection of right material for a right application, you are half for good done. Right? If you selected a wrong material, it means for any material, it has to be go through by rigorous testing. Means space is more environment has to be faced. Space environment means deep vacuum conditions. Means minimum 10 to the power minus 7 torr is a vacuum level minimum, right? Condition temperature condition is extreme when it is in front of sun. It's near about 150 degrees Celsius in a daytime. The same time when the sun eclipse are there, or I can say when sun is not there, or indirectly when sun is the opposite of that, the temperature reaches to minus 150 degrees Celsius. So in a one day, the total time, I can say total uh, time cycle is approximate variation is plus minus 300 degrees Celsius. Means overall a one day cycle is 300 degree plus 150 minus 150. Now you imagine a material which is having a very good strength, maybe let us suppose on the room temperature, but it is going to lose its property because of this thermal cycling, right? Because every time when you're going for a fatigue loads, especially with respect to temperature, it is going to lose its property drastically. Third thing is deep vacuum conditions, as I mentioned, 10 to the power minus 7, right? Thermal cycling, almost 300 degrees Celsius variation in a one day. Then charged particles are there. So if you go to the space, let us suppose less than 500 degrees Celsius, the charged particles are very drastically reduce the mechanical property of material because of corrosion and erosion. So selection of proper material with respect to proper, I can say height, or I can say the specific kilometer, then only the right material can function. Otherwise, the satellite which you design for next 10 years or 7 years, it is going to be work only for sufficiently for 1 year. Right? It will lose the property. And there are so many missions we have lost because of wrong selection of material. Right? So there are so many cases are there. Even a selection of wrong material for a particular purpose has lost the entire mission, and we lost so many millions of dollars because of that only. So I will touch upon some of the things which is right now we are using. As I mentioned, there are so many evolution has been done in material science category. So we started from the so many dark age, then resonance. After that, right now we are in the I can say the new category of material, or the new age of the material, which is used to be called a smart age or intelligent of material, right? So the actually conference, this title is very unique for this purpose actually, for it, especially in terms of space science and technology. This is actually emphasizing what kind of material right now we are using, right? And so many actually research is available. So those who are really interested to work in a material science, so a very good platform actually provided by this conference. Anyway, as I have started in morning itself, I told that there are. So we started from the, I can say Stone Age, right? मतलब पाषाण मतलब जहाँ से हम पत्थर यूज करते थे ना, Stone Age category. Then after that, slowly we understand the iron. Then slowly we understand the alloying category, means a bronze category. Right now we are living in a smart or intelligent category of material, which there are so many piezoelectric materials are there where you are using it. Smart category of material we are using, smart materials we are using, especially in terms of magnets. And there are so many electronics materials made of these categories. So if you talk about metals and alloy, there are n number of material we are using. So if you talk about aerospace and space, more than 300 category of different category of material we are using, which is steel, alloy, aluminum, magnesium, etc., beryllium, copper. Then combination of so many materials are there. Each and every material having its distinct advantage, same time limitations are there. So we are using their best possible way to utilize their best property for as per our applications, and they as and one small actually and for your information only, the government of India, especially the present government, is basically concentrate more and more on Indianization of space materials. It means that the material which is right now not processed in India, still we have to bought from other countries, those actually making such kind of materials. So now one mandate is given by government of India through Indian industries, we have to develop such kind of critical materials, right? So those material which is right now we are buying for the other countries, very soon you can see that especially Indian industries, or I can say those who are working in the R&D area of materials, like Midhani, Mishadatu, Nidam Limited, then Tata Advanced Materials are there, and sometimes some of the specific labs of ISRO as well as DRDO, we are processing such kind of material and we are developing such material on the lab level, and after that we are productionizing to giving as a technology transfer to the Indian industry, so that in the bulk category, or I can say in a large, we can produce such kind of materials. So some of them is there. One specific materials like tungstens, right? Cobalt, nickel. These materials are basically we are developing. And one small instrument which is I can say the main mandate of government of India, na, especially for those who are very critical. So one instrument name is called TWTA, traveling wave tube amplifier. Those who are understand, or those who are belongs to electronics fraternity, they can understand if they want to enhance. If you want to enhance your ground signals, means if you want to communicate entire globally, अगर आपको पूरे globe को cover करना है, right? If you want to cover entire globe through your satellite, so what happens when the signals from ground will reach to the geostationary orbit, right? Satellite, na? So there are so many losses are there. So these losses will reduce the strength of your signals when it is reaches to the geostationary orbit. So you have to once again enhance the or amplify the signals. Then only you can spread over the globally. So one instrument is called TWTA, traveling wave tube amplifier. Its cost is it is a size roughly I can say 1 feet only, and it is like your printer size, a small A4 printer. But its cost is near about 8 crore rupees per piece. And all over the India, means all over the globe, only L3Com and Thales, two companies are there who are making such kind of TWTA. Any missile means all over the world, any kind of missile, any kind of through output satellites are there, right? It cannot be fly without TWTA, right? Or your aeroplanes are required. Sometimes you used to call the black boxes, na? So it is basically communicate your system to the ground. Understood? And TWTA cost, as I mentioned, it is 7 to 8 crore rupees per piece. And on an average, if you think about that, any high through output satellite, the near about 30 plus TWTAs are required. Any missile, minimum 4 to 5 TWTA for ground level. For any satellite, minimum 30 numbers are there. For rocket also, we are using 1 and 2 numbers. And as your satellite size will increase, the TWTA numbers also increase. Now you can understand how much FE, foreign exchange, will go. Understood? Now we are going to indigenize this material, and because of the indigenization, such kind of typical property with respect to compatibility, new category or new generation of materials are coming to picture, so that up to till life, its life is near about 15 years. So next 15 years, the satellite has to communicate to ground through only this. And just imagine 7 multiplied by 30. So the satellite costs only 210 crore rupees. I can say more than 200 crore just because of spending on TWTA procurement. That's why the satellite cost is almost, if you see, normally we used to call 300, 400, 500, such as Chandrayaan 2. Its cost near about 590 crore rupees. And very cheap. 590 crore, na? So now that's why we are telling you, we want to indigenize such kind of critical and complex technology, and it starts from the material only. If you understand the physics or the metallurgy, or I can say the process of your critical materials, or I can say the noble materials, then only you can process it, you can manufacture it. Otherwise, TWTA cannot be made in India. It cannot be indigenized until unless you cannot understand the behavior of your materials. Right? Because it has to be work 10 to the power minimum -7, as I mentioned. So temperature things are there, vacuum is there also there, right? Interaction with other materials also there. So many complexities are involved. So this is a typical TWT elements are there, right? And these are the piece parts are there. So this is actually SW structure of TWTA, which is made of tungsten. And so many piece parts are there. And this is actually what right now I am working. We have initiated this activity. Still, it is in a good shape, but not we can proper. I can say it is not in the production phase, or I can say fully developed. But this is actually what we are doing for our payload development. This is called TWTA. In general, there are so many materials we are using. Same time, there are so many dielectric materials are there, like alumina, PTFE, BMZ, quartz, ABPN. So most of the ceramic materials comes into category, and those who belongs to that, especially for electronics fraternity, they can understand that the ceramics actually playing a very vital role for dielectric properties, and so many. What happened? So many ceramic materials are there, which is a part and parcel of your TWT, as well as so many electronics applications are there. Because of their dielectric property, we are using for development of our payloads. Optical and structure materials. As I mentioned, there are so many optical materials are there. If you want to make a sensors, if you want to make a cameras, right, like Mangalyaan, Chandrayaan, we are capturing so many good photographs of interplanetary missions, or I can say so many photographs of your Earth to Earth observation through our EO payloads or optical payloads, right? And optical payloads only can work on the daytime; they cannot work in the night time. So the solution is microwave remote sensing payloads, with MRSA payloads, right? So they can work 24/7. Means they don't want any medium, right? Microwave can travel in. They don't want required a light for that. So that's why if you want to capture a good images, especially for the Earth observation, because you want to know the information of your weather conditions, right? Resource monitoring, disaster management. So we require such kind of satellites are there who can actually give the 24/7 information, especially for the military defense. So for that, we want optical payloads, and optical payload means, as I mentioned, for payload application and development, you have to select a proper material which having the property which is less density, same time the very lightweight. So there are so many options are available, but in terms of one property is called focal distance. Right? When light is come, then detector will capture the image like your camera, na? So when you are clicking some photo, image will capture on your detector. Right? Now imagine a 300 degrees Celsius variation throughout the temperature time in a daytime, right? Overall 1 day cycle is there. And imagine no material is available which cannot, I can say, expand or contract in a temperature. It means you don't have any such kind of material. Koi bhi material hoga, any material is available. To be very frank, as such, any material having a tendency, when you are giving any thermal energy, it will either be expand or contract. It means there is always chances that distance of focal distance will change. Understood? But in satellite, if you are putting a satellite up to 500, 700 or 1000 kilometer orbit, and if any changes are there, it means the proper image cannot be captured. And if image is not captured properly, then this satellite is going as this satellite is not meaningful. Yeah, whatever the images are there, that is not meaningful for us. So we want to select a particular material which is housing for your camera, or I can say which is housing for your camera material, but it cannot be contract or expand. So new category of material development is called INVAR, invariable, which is Fe nickel alloy with respect to some small amount of cobalt. So even though plus 300 degrees Celsius variation in a daytime, or maybe the overall thermal variation in a daytime, it is not going to lose, or it cannot be going to like CT, coefficient of thermal expansion. It is not going to change with respect to temperature. So this is the based on the application we decided, or we develop a material, right? Such kind of so many materials are there we developed. Such as if you want to work a payload or satellite up to 7 kV or 8 kV of power, you understand 7 kV kilowatt of power is required to operational satellite, or I can say the spacecraft. Now 7 kV power is there, so then how much heat dissipated, how much heat will generate? It has to be dissipated through the space, na? If it is not dissipated, then definitely the thermal imbalance will be there. So you have to develop a new material which is having a higher thermal dissipation. We called it as COAR. It is once again a category of Fe nickel, but small amount of cobalt we are increasing. So such kind of this novel material we are developing as and when our requirements are there. So these are the material which is a special category of material we have designed and developed especially for our payload applications. Same morning itself, that professor has told such kind of magnetic materials are there, right? So as I mentioned, even though there are so many materials still we are procuring from foreign countries, or I can say from other countries, but there are so many Indian activity initiated in India, in magnets also there, in which new metal, magnetic core, soft iron, these are the material we are developing, such as soft iron, looks very small, or lag raha hai, it looks like soft iron means a category of iron, right? But this comes some kind of material, magnetic material, which is we are using a internal property of Fe to magnetize this material, and this material is very useful if you are triggering on the TWTA, right? Because you have to balance the material, you have to set the material with your magnetic properties. So the soft category of soft iron is basically a ferritic material which is actually going to use for TWT triggering material, right? Same time, piezoelectric materials. This is in general you read in your 11th, 12th class reading books also you heard. Piezoelectric means when you are converting mechanical energy into electrical energy, right? And when most of the sensors is made of piezoelectric, especially there are so many robotic projects you did based on your piezoelectric only, right? And there are so many piezoelectric material we are using, but in general we are using a quartz, lithium, titanium. These are the material we are using for it. And those are I am explaining. These all is basically used in a spacecraft for payload developments. Composite. This is actually solution of most of the problem, especially talk about launch vehicle, means rockets. So when you are fabricating a rocket, you are making a rocket. So our main intention is to be make a structure lighter and lighter, but same time it's strength in all direction. Means directional property can have a very good directional property so that the purpose can be solved. So the composite, especially the carbon composite or the different category of metal with composites, right? So these are the material which actually gives the solution of our most of the aerospace problem, especially in terms of if you talk about antenna, like there's so many antenna elements I have shown, like reflectors, antenna. We are using it radar applications. Same time, so many structure members like PS3, PS4, right? Stages of rockets we are making for composites. So they have very lighter in weight, but at the same time their strength, or I can say specific strength, are very, very high. Where is my pen drive? Pen drive? Yeah. Huh? Okay, I will show you how actually rocket this kind of composite materials we are using and where we are using this kind of materials. You can have sound. It's not coming. तो आई नहीं रहा है. So copy कर दो, चलो डेस्कटॉप पे हटा दो, पेन हटा दो. इसको copy कर दो. कॉपी कर दो और डेस्कटॉप पे डाल दो. हाँ, डेस्कटॉप पे ले लो इसको. डेस्कटॉप पे कौन सी थी? So okay, right now I am going to talk about launch vehicle, this aerospace field. So there are so many different category of materials. So that I will show you one by one which kind of material we are using and which stage we are using. So I am talking about a launch vehicle which is launched Chandrayaan 3, which is called LVM3, or I can say LVM3 Mark 3, right? So 22nd July 2023 means last year, na? Then we have launched Chandrayaan 3 from this rocket. So how this rocket looks and how it is actually launched Chandrayaan 3 and how it has landed on the moon on 23rd August 2023 last year, right? Issue hai kya? So this LVM3 rocket is right now the highest lift-off rocket of ISRO, right? Till now, we don't have higher capacity of this rocket. And after that, we are going to make it HLV, means new generation launch vehicle, NGLV, we are going to make it. Okay, done. Thank you, sir. Thank you. So now you can see that this is the rocket. So this is the rocket which is called LVM3, or I can say Launch Vehicle Mark 3, which is launched Chandrayaan 3 on 22nd July 2023 at around, I think around 2:15, right? 2:50 p.m. How it looks, you can see that the total weight of this launch vehicle is approximate 640 ton only. So total weight of this rocket is not more than that, only 640 ton, or in other way I can say 6,40,000 kg. Right? Its height is not more than that. Its height is approximate 43 meters, or I can say approximate 10-story building. Right? And when it is going to inject a satellite in a desired or particular orbit, its speed is approximate 10⁻⁷ kilometer per second. So the weight is approximate 6 lakh kg. Height is approximate 10-story building. Speed is near about 10.7 kilometer per second. So now you can imagine how much gigantic or a complex technology involved to manufacture, or I can say fabricate such kind of difficult launch vehicle, right? And this launch vehicle total regime is approximate 5 to 6 minutes only. And after that, all the parts, first stage, second stage, third stage, will be separate out from the main launch vehicle or main rocket and fall down to the Bay of Bengal, right? Only and only satellite will go to the space, and all other things will be separate out and fall down to the Bay of Bengal, because our Sriharikota Satish Dhawan Space Center, the space port of India, is near to Bay of Bengal, right? It is called expandable launch vehicle, or I can say not reusable launch vehicle, right? It is not a reusable. Means one time only you can use it, second time you cannot use it. That's why all the things now which is going to be fall down and go to the Bay of Bengal. So it looks very, very simple. There are 3-stage rocket is there. First stage is a 2-strap-on. If you compare with normal human being, so if it is a nozzle of your rocket, you can understand that approximate 6 feet height is how human is there. Na? It is less than their own nozzle. So this is a 200 ton of STPB fuel. This is also 200 ton of STPB fuel, 400 ton, 110 of liquid engine, and last stage is a C-25. Its total weight is approximate 640 ton, but only it can carry only 4 ton of satellite in a geo orbit. It means you can understand the mass fraction, or I can say the payload divided by total launch vehicle. It is in a points, means 0.001, means efficiency wise or payload point of view. You see, it is not less, it is a less than 1%. So now you understand it to cross the gravity. It's basically a major challenge for rocket. How it looks inside, like this only, and this is the topmost portion where is actually your satellite encapsulated, or I can say Chandrayaan 3 was encapsulated. If you are comparing with all other launch vehicle or all other rockets of ISRO, so this is the right now the heaviest launch vehicle right now available with ISRO, right? And since this is launched from Sriharikota, now the next question comes: why only all the rockets will be launched from Sriharikota? Any specific reason? क्या लोकेशन में ऐसा क्या वहां पर? Why not Jabalpur? near to equator. Good. So the geosat has to go to near to equator because geostationary means it has to float around Earth on equator. So that's why it's near to equator. This is the second best site of the world after French Guiana. After French Guiana, this is the second best site of the world which can put a geostationary satellite in orbit. Next, it's not only one answer. And it should be near to sea. That's why any malfunctioning happen or something goes wrong, at least you can save the lives, right? It should be away from the dense or civilized area. Okay. Next. Why only eastward? If you see the map, it is eastward of your Earth or eastward of India. Why only eastward? Because Earth is located on an axis to west to east. So that's why we want to use the Clovis force, which is responsible for rotation of Earth, so that, like I can say, the launch vehicle or fuel we can save it, or economically we can make a launch vehicle efficiently, right? So these are the reasons are there. But anyway, this rocket actually will launch from Sriharikota. So already launch it. Whether you want to launch it with you, आप लोग launch करना चाहोगे यहाँ पे अभी? I am asking you whether you want to launch it or not. तो already launch कर चुके ना? But still you want to launch it? So you can launch it, no problem, because it is in front of you now. So now GEC Jabalpur student will going to launch this rocket. They will launch it. So normally for any rocket, we have to go for a 72 hours countdown. Normally 3 days countdown will be there, which check all parameters of rocket. If anything goes wrong, rocket will not rocket will not launch. So we assume that everything is okay. So now we are going to launch this rocket. Here is GEC Jabalpur, right? So shall we start countdown for 3 days? So last 10 seconds people will remind and this rocket will be launched. Okay. Shall we start? Okay. 10, 9. And after that it is going to become a circular orbit. And this C25 means cryo, liquid hydrogen as a fuel, or liquid oxygen as the oxidizer we are using. And this will put a satellite, or I can say Chandrayaan 3 in the indicator orbit. And after that we are raising the orbits. And it will detach with the speed of 10.2 kilometer per second. So this speed is required to counterbalance your gravitational force of 9.8 kilometer per second, meter per second square. So this speed will actually give a centrifugal force which is counterbalance your gravitational force. Then only the satellite will be rotating forever its desired orbit, right? And if you so this is the small snapshot of your rocket. So most of the new generation raw material we are using, and there are so many, I can say, research is going on, especially on the phase change material, because we want to use the material when it is required. Especially we are using the thermal property. So phase change materials basically comes around this category where thermal property is important, right? Same time self-healing material, somebody told that we are using a self-healing material in a Mars orbital mission, or I can say MOM first, right? Shape memory alloy we are using for a deployment of satellite, especially antennas. If you see that, your umbrella you can see, when there is no requirements are there, it is a stochastic mode, right? And when it is going to require, when rainy season you are opening it. Same way all antenna, where they are going to launch it, they are in a stochastic position, and when they will go to the space, they will deploy it, right? So next month means March, we are going to launch NISR, NASA ISRO synthetic apart satellite. It is called NISR satellite. Its antenna is approximate 30 meter. आप समझ रहे हैं इतना बड़ा एंटीना, the size of this antenna is this much big, Now it is going to be, it looks very, very big. Now for any Earth observation, and this is the one of the highest, costliest satellite till now, world has been made it. Its cost satellite is near about 5,600 crore rupees. It is going to be launched in the March end, and it is a collaboration of NASA and ISRO. Right? The same way the shape memory alloy will play into picture when you are going to deploy, especially antenna in space. Right? So these are the new generation of launch vehicle, or I can say new generation of material we are using for space as well as aerospace area. Right? And as I mentioned, there are so many criticalities are available, because anything you want to deploy in a space, it has to be tested and qualified on ground. Because you cannot take any risk, because space means simple definition: no air, no repair. Understood? You cannot repair it. Anything goes wrong, you cannot go there and repair it. So you have to test and qualify on the ground level, then only you can utilize it, right? So this generation of material is basically new generation. I can say 3G or 4G, or I can say 5G of category of material we are using, and slowly we are injecting such kind of material, especially for our payload development, satellite development, or launch vehicle development, right? Any questions are there? लंच हो रहा, सबको पता है, लेकिन कुछ क्वेश्चन तो होंगे ना? पहली बात तो मतलब फर्स्ट ऑफ ऑल थैंक्स टू द ऑर्गेनाइजर्स कि दे हैव गिवन मी चांस कि दे कैन शिफ्ट माय लेक्चर बिफोर लंच. अंडरस्टूड? बिकॉज आफ्टर लंच ना वेरी डिफिकल्ट टू, एक तो लेक्चर देने वाले के लिए भी डिफिकल्ट होता है लेक्चर दे, सेम टाइम फॉर दोज हु आर लिसनिंग ना उनके लिए भी डिफिकल्ट होता है कि वो ग्रास कर पाए, पकड़ पाए ना, समझ रहे हो ना? सो थैंक्स टू द ऑर्गेनाइजर, थैंक्स टू द GEC Jabalpur, right? Thanks to the Kamal Kushwaji, Department of Physics, Bhovia ji, even those who are actually invited for giving me a lecture, expert lecture for this. As I know that the scarcity of time, I cannot touch each and everything, but still, for your understanding purpose only, I can show you. If you want to have any detailed discussion, so sometimes what happen in front of asking a question for so many people, sometimes people are hesitating. So I'm available up to full day. So if you want any ask any question, so I'm available during lunch also. We can talk, but only one small request, मेरे को भी lunch लेने देना है, ठीक है ना? चलिए, no question. This means किसी को भी कुछ समझ में नहीं आया है. भाई मुझे तो यही समझ में आता है, अगर क्वेश्चन होते तो समझ में आता है, और किसी को कुछ समझ में नहीं आता भी क्वेश्चन नहीं आते हैं. करेक्ट ना? करेक्ट है? गुड. So no question?
Thank you, sir, for the session. It was truly interactive and informative. I request our session chair, Dr. G.S. Thakur, to please share his thoughts on this session.
Good afternoon, distinguished guests, all HODs, faculties, participants, and my dear students. It is an absolute honor and privilege to stand before you today to express my heartfelt appreciation for Dr. Ravi Kumar Verma, Scientist, Space Application Center, ISRO, Ahmedabad. Sir, your insightful lecture has been a true highlight of this conference. Your ability to connect theory and practices, coupled with deep expertise, is a gift to all of us here. You have left us with new insights and ideas that researchers and scientists can use in their work. On behalf of everyone at this conference, I thank you once again for your contribution. We look forward to following your continued journey and remarkable work that you will undoubtedly continue to do. Thank you so much, sir.
Thank you, sir, for your valuable thoughts. I request our session co-chair, Dr. Adya Mishra, to please share thoughts on this session.
Respected keynote speaker, Verma sir, the chair of the session, Dr. Jiten Thakur, sir, the convener, Dr. Kamal Kushwaha sir, and all my colleagues, volunteers, and dear students, scholars. You know, when we talk about the material, what I learned here with very informative lecture, but I observed that mass and volume for a payload is very important to get from TWT to the generation of a device launching for geostationary devices. That matters. मुझे वो विद्या याद आती कि जब धनुष से तीर मारना है तो वो थ्रेड किसका बना हो जिससे हम उसको जब पीछे खींचेंगे तो तीर उतनी पावर से आगे जाएगा. तो हमेशा वो थ्रेड कैसा हो, ये हमारे पुराणों में बहुत वर्णन आया है कि किस चीज का वो धनुष का थ्रेड बनाया जाए कि लॉन्च हो. So here whenever we talk about the material, it means we talk about the physical device, and without physical device no technology can be implemented. And for that, the researcher or engineer is a designer. What I have learned here, that mass and volume and what efficiency factor is to be considered, that was insertion loss. Control the insertion loss by so many factors. Yeah, but I had a query that you have given, sir, the journey of material, structure material, functional material, then multifunctional material, then last you have mentioned the intelligent material. So, because I belong to artificial intelligence, I have a question. Then what was that? The intelligent material, is that the functionality properties or whatever it is? So I want that answer behalf of all the scholars. I thought somebody will ask this because everything is now controlled digitally. Then how you are managing this intelligent material? सर को माइक दे तो वो मैं थोड़ा इंटेलिजेंट मटेरियल का जरूर सुनना चाहूंगी. ये हमारे लिए बहुत अपॉर्चुनिटी होती है कि लर्नेड स्पीकर्स हमारे बीच में हो, और मेरी भी क्वेरी है तो मुझे उस तरफ क्वेरी पूछने के लिए मिला नहीं, तो ये जरूर है कि उसको थोड़ा हाईलाइट करें सर. Yeah, you have given the journey of material like structure material, functional, multifunctional, then last intelligent material.
Ma'am, this is also new category of material.
Yeah.
This kind of material we are using for robotics applications.
Yeah.
Very soon you can see that this robot can take his own decisions. But since this is a humanoid, so how they can take the decisions, right? So based on the neural networks, new category like AI, this we are using now. So they can take our own decisions. So we have to develop a material which can sense like us. So that's why this category, new generation of material, which is called the intelligent material, and so many work is going on this. And very soon you can see that humanoid will take all decisions like your human, like you only, or humans only.
Thank you so much. This humanoid intelligent sensor matters. How this robotics, they said humanoid robotics is converting your sense. Material is converting your sense, and everything is converting on the basis of sensor. Very beautiful journey of sensors we have seen in the lecture, and that was focused to the launcher and all satellites. So it was really overwhelmed for all of us, and thank you so much for so informative lecture. And I have me myself learned. I hope that everyone has learned this. Thank you so much.
Thank you, ma'am. Now, I will request our convener, Dr. Kamal Kushwaha, session chair, Dr. J.S. Thakur, session co-chair, Dr. Agya Mishra, and co-convener, Dr. S.K. Mahobia, to please felicitate Mr. Ravi Kumar Verma with a shawl, shreefal, and a memento.
It is requested to all participant and all audience for a photo session over here. एक फोटो सेशन यादगार के रूप में हो जाएगा. वॉलेंटियर वो कॉन्फ्रेंस का वो लगाओ. नीचे फोटो सेशन के लिए हम लोग एकत्रित होंगे. पार्टिसिपेंट से आ जाए.